guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. Man, talk about a busy ass day. I called this guy at 10 o'clock this morning. We talked about what it was going to take to get this thing running. I've been trying to shoot this little segment of the video since 10:30 this morning. It's now 3:30 in the afternoon. Gentlemen, we've got yet another sb220. Now, look, I'm not going to lie, I'm down to 2 of these left on the shelf, and I like to have 3 or 4 of these in here at all times. So if you have an sb220 out there you want me to work on to put my delicate digits inside of, ooh baby, send it here. Now's the time to send. Send them now. Like right now. Okay. Now I got that little bit of the promo out of the way. First things first. I don't know if you guys can remember back about umpteen million videos ago where I fought sb220. And come find out my blocking cap was like as soft as a rubber eraser. And it was leaking through the cap. Well, this one, it's softer than that last one that was leaking. So we're going to replace that. I got to check this blocker. This has some sort of aftermarket capacitor bank in it. Now, on the upside, you guys, this has got the Harbach parasitic system in it. The one from about 5 years ago. And this thing is remarkably clean on the inside. It's got the upgraded Harbach high voltage board in it. He does have some blue LEDs in here, but the other problem is, which I totally dig, this board is not bolted down. There's 110 volts line level line on there that's hot all the time, so we've got to bolt that down. Now, this does have the Harbach soft key kit in it, which was featured in the last video on how to assemble it. This has got the Harbach soft start, completely useless, which was also featured in about 8 or 9 videos ago. It's got an aftermarket. I mean, there's a lot of aftermarket schmoo on the inside of this thing. I'm here to tell you what. I'm just saying. It's got the aftermarket load knob in it from RF Parts, which I'm not a fan of, but it's okay. Personally, I feel the stock one is more than adequate to do the job. And the reason that it arcs on the load is because you're already too far out of resonance and the capacitor is getting overwhelmed with harmonics. So to get it not to arc on the load band or the load knob, you've got to retune it, couple it just slightly different. Somebody's gone in here and done a really brave grounding of the grid system. I've got some really interesting wire going on here, but this copper plate up here, this is cute. Let's make sure I got this in frame, which I don't. Sorry about that. There's a copper plate system that's here that needs to come out. We need to replace it with something else. The other problem is we've got some little telltale signs here. Do you know what these are? Do we know what these are? I know what these are. These are the pins out of the base of a 3500Z tube. And the reason that they're here is because they were in the tube sockets. This one's missing the pin completely. This one has the pin, but it was snapped off at the tube. So what I tell these guys that run these real heavy, especially the 80 meter, the 80 meter, 40 meter clan of followers that I have, it's really smart if we take and we put some extended legs on these of some kind where we can set the amp up a little bit, and then take like a little 120 millimeter muffin fan and just let it move some air on those pins. And that's more than adequate to prevent this. So we have to assume that the grids on the tube, when they became ungrounded, they most likely arced over internally, so that means we got to come over here and check this section of the amp too. All right, I'm going to do my dirty now on this thing. And we're going to start on the bottom side and we're going to work to the top side as always. So the other thing that we got to redo is the power lead thing is completely shot here in the back. So we got to restrain relief that and start over. So when we cut back, we'll be working on the bottom side. We shall return. Well, not the worst decrusting of the the kludge ever, but this thing was, they even went through the process of drilling holes through the plate and then tying it in place with wire, and then couldn't even solder it well enough for it to actually make contact with the pins. I have a strong feeling that the tubes that were in here were complete junk. This was all tied together like a squirrel's nest on the inside, on the base of the tubes here. This here, shoot. And the power wire is just about on its last leg. I did do quite a bit of scraping to, literally had to take the wire after I trimmed it back here and heat shrinked it up so it could be strong enough not to break on you again in the foreseeable future. This wire is pretty corroded, so I had to take the wire and fan it out, and then I had to sit there and scrape it on both sides to get enough exposed copper because it is so oxidized to accept solder, but we were able to overcome that. So we got all this cleaned up. What I wanted to bring everybody's attention to is this here. I've only seen this on one other amplifier. I think that's a Harbach mod issue right here. We're going to pull this out and we're going to replace this with the 0.01 disc capacitor because it's equally feeding both of the filament legs with signal, which in theory will work, but I think that we'll get a little bit better operation if we go another route. So on that note, that's where we're going. Well, let's see. The bottom side all cleaned up. Let's zoom on in here. It's a lot of work to get that all cleaned up, but it's done. So where we flip it over and we're going to disable the high voltage side by disconnecting it from the capacitors. And we're going to turn it on and we're going to start checking our filament voltage and check out our soft start and check out our keying circuit and check out all the little peripherals first. And then yeah, we'll check out the high volt side. So let's flip it over and we'll get started on that. Get the trusty dusty fluker out here. Put it on diode check. What we're checking to see is if we have a hard short against our protection diodes. COOL, not KWELL. Okay, so before I bring a high voltage board on, there's a couple things I want to do to it first. But first I want to check out all of our low voltage systems, which entails me going in here and lifting this one leg out of the way. Hot. Okay. Now, there's only 1600 volts there, we can cheat just a little, not a lot. So we have a max insulating effect of 600 volts here. And this is theoretically how it works. This isn't really trustworthy, but we're going to cap this off and heat shrink it a couple different times. To protect ourselves a little bit. And protect the circuit. And then the trick is we'll pull the side flap off. So greatly increasing our ability to be insulated from ground. Which will provide us some protection. This is a basic rub, no contact insulator. This isn't for direct exposure insulation. Now, technically, in theory, we've just created an 1800 volt insulator. Me personally, not buying that. But we're going to give ourselves a little bit more of a prayer than if that wasn't on there. And the trick is that we have it hanging out in free space and we don't actually put our hands on it or touch it or come near it. So it's kind of a ghetto hood rat tactic, but it'll work. All right, let's reorganize here. It's the simplest of the simple tests. Let's listen close. Hear that click? That's the soft start disengaging. See why I think it's bullshit? Because you gotta add a rectifier unit. There's no time delay. There's nothing, it's instantly on. So, it's me personally. Horseshit. So either they've got it set up so that the time delay is in milliseconds, like faster than sound can travel, because we can't hear it. Relays are instant on. See, the whole idea behind a soft start circuit is that you let the voltage slowly creep into the capacitors, which extends the life instead of hitting them flat out, because when they're fully discharged, the way these things sit, for a hot New York second, literally about 500-600 milliseconds at this low of a voltage, even in a doubling device like this thing, the power supply sees the capacitors as a short for a hot second. Very quick hot second. There's no time delay there. Those relays are instantly on. I've installed this for people instantly on. Just telling you. This is a weak link built into the amp. But ham guys love it. Cool, 5.6 volts. 5.36 volts. Okay. Oh, Cletus is on camera. Oh, beautiful. We're safe to put tubes in it. Okay. So, let me show you the things that caused me pause for this thing. And honestly, I think it's from the grids being all screwed up on the bottom. I mean, first things first, we're going to bring the high voltage on board, but so we have to wait for anything. The caps aren't charged. Instantly go to work on it. So those of you that watch every single thing I do, that's a tip for you. Okay. Let's go talk about this for a hot minute. Can you see it yet? I can't see it. Is it going to focus? Nope. So down in here is an 1/8 of a watt resistor. Now it's supposed to look something surprisingly like this. Like this here. 3 watt. It tells me that there's been a couple different problems with this thing in the past as far as the plate amp circuit goes. Which tell me the grids have gone buck wild on this thing at one point or another. So instead of getting the right part, they've put this little 1/8 watt resistor in there. This is supposed to be a 3.6K or 3600 ohm 3 watt resistor. So we're going to change that out. 5 watt, okay. I'm going to question that here in a minute. The last thing that I want to do is I want to change the doorknob out. And then I feel pretty comfortable after we get the doorknob changed, this here. I'll show this thing to you. It's soft. Back in here is the mounting board for the lights, which are white. He said they were blue, but these are white. There's a mounting board I got to mount down for that. So I'm going to do those things. I'm going to change this resistor, mount that down, change this cap. We'll be back. Tubes are lit. It's a good sign. Okay. Well, on to the next step. We're clicking right along on this thing. Will it happen? Will this be the very first sb220 to ever come in here where I don't have to take the faceplate off? Doubt it. Okay. Well, let's bring the high voltage on and watch what happens. Oh shit, I gotta do the doorknob. So here we are 3 hours later. This is the blocking capacitor that's in here. Check it out. That should be as hard as a brick. Just in case we missed it. I shouldn't be able to oval it by squeezing it. This is just about as hard as like the old pink gum that we used to get that was made to look like barrels and stuff. This is no good. So I went ahead and replaced this with a new blocker, and ta-da! We got high, we got low. Now what we don't know is if it's going to tune and load out. So of course we're going to start in a 10 meter position, but then we're going to work in the other direction. We're going to go all the way down to 80. Because the guy that owns this thing says, I want it to work everywhere. I said, okay. So, for us to do that, I got to set the workbench up for that. It's currently 6:30. I'm going to take me a dinner break, and we're going to come back. We're going to finish this thing real quick. I'll be surprised, because it'll be the first one that I've ever worked on where I didn't have to take the faceplate off and adjust the inputs on something. But it should be relatively close, so we'll see what happens. 10 meter, might need to play with that a little bit, but we'll see what happens when we go to 15, 20, 40, and 80. We'll be back. So we had some problems initially when we first turned it on. The band selector on this thing is dirty and not making great contact on the 10 meter position. So what we're looking at here is right here is a 5 watt slug and reverse, 1000 in peak, or 1000 in average, 1000 in peak. And I want to show you what I'm putting into it for drive right now. About 90 watts, right? We're getting 900 out, and that's in a high position. So we can see, as we can see here, we're in the sideband mode, which will help it a little bit. Here's the problem that we're having. Tilt this just a little bit more. So we're going to look at this needle here. This is a 5 watt slug and reverse that sits between the 955 and the sb220. This is without the amplifier engaged. Here's the amplifier in line. Face has got to come off. It's over 5 watts worth of reflect with 90 going forward. That's unacceptable. If I was to send this out to the customer, he'd be calling me crying that the input SWR is too high. So, on that note, but this is a good bit. Check it out. High voltage meter's working. Relative power meter's working. And the grid meter's working. So all the controls in the front of this thing are actually working the way they're supposed to. The band switch, I'm going to go in here and clean it. I think that we can repair this as long as it doesn't break when we go to pull the face off, which it shouldn't. But I've had that happen. When we undo this nut that supports the band switch in the back, just that a little amount of movement has caused it to snap in half. So we're going to be very delicate. And we're going to try and take the front off this thing real fast, and we're going to see if we can get it to tune in. Okay, not giving away any secrets, but first thing I'll say is knobs should not be held on by super glue. That was a challenge, but I have a solvent over here that doesn't dissolve plastic, but it makes super glue soft, so it allows me to be able to get in there and get the set screws to come back out. So we're able to salvage these screws, or the set screws and the knobs. So once again, 1,000 in peak, 1,000 in average, 5 watts, 7 reverse. It's the same amount of drive, 90 watts of drive, which I'll show you here. Same drive, but watch. 1,000 in the corner. Now this will help you big time on the big end when it comes to doing things. Here, check this out. You're gonna love our input reflect now. This is crazy. So that's a 5 watt slug in reverse. Talking through the box, amplifier now in line. And it doesn't matter if you're on 10 meters or 11 meters, they tune exactly the same. Now I can do this legally because I'm in the middle of I'm dumping this right into a dummy load. I'm not in the middle of anything. I'm dumping it right into a dummy load that's grounded, so I'm not effectively radiating anything into the atmosphere. So right in the middle of the 10 meter band, and same exact input tune, which is awesome sauce in my opinion. That's what we're looking for. So now that we've got the 10-11 meter band kind of unmessed up, we will go and we'll play with all the other bands. So let me bust out my my little starter kit 7300 radio and another bird meter and an integer of coax of 3 foot. Everything around here is tuned to the 369 principle. Okay, so all the coaxes lengths are either going to be 3 foot or going to be 1 foot, 3 foot, 6 foot, 9 foot, 12 foot, so on and so on. Not too sure if I'm a fan of this new fancy dancy microphone I got hanging on the top of my frickin' camera here. Okay, so we're on 80 meters, and we're going to leave this an average. Okay, the entire time. Here's 80 meters. This is what we're passing through the amplifier for drive. That's on sideband, as you can see. So our peak watts are like 2 times that. Let's turn this in reverse. It's a 100 watt 2 through 30 megahertz slug that's in there. Now that is like less than a watt on 80 meters, fully tuned. Over here once again, make sure that wire's not in frame. It's not, for the most part. We're gonna have our 1,000 watt slug here, average, peak. Thing is working perfect on 80 meters. All right, let's move on up. Okay, so here we are real quick on 40 meters. We got the input all tuned up on this thing. Let me show you what I'm putting into it for drive. Same 50 watts. Flip that around in reverse. And let's walk around here and we'll step on the pedal. Radio's not freaking out. That meter's not freaking out. Pan over here. Once again, everything's set up the same. Got down. Okay. 40 meters. Good. Let's go look at 20. We'll be right back. All right. We're on 20 meters. Got everything zeroed out again. So, there's our 50 watts input once again on 20. I'm going to lock this. Step on the pedal again. No, we got a little bit of arc in it, slightly out of output tune. Small adjustment. Nice and flat on the input. Nice and flat on the input. Sorry guys, I can't do this right now with you all. Nice and flat on the input and good peak power on the output side. Once again, we'll verify the bird, what it's telling us with the meter on the front of the 7300. Not even moving. Okay, last stop. The deadband, 15 meters. Let's go take a look at it. Okay. 15 meters. I did have a little bit of arcing on the tuner. And I had to go in there and spray some special high voltage chemical wash on the tuner and got it to stop. So, on that note, I'll show you what we got going on for drive. Flip the needle around or the meter around. Did have to adjust the slug a little bit, but we got it really low for you here. But our 50-60 watts of drive, of course. Let's turn this back around to reflect. And we're going to go ahead and we're going to pan over here. More than adequate output power for about 120, 130 watts going in. So, let's come over here, stay consistent there, BBI. We're going to look at the meter on the front of the radio. Did not freak out. Good reflect. We're done. Of course, all this measuring was done in peak power because that's the way this community looks at powers in peak. The CB community looks at everything in average now. Whatever, tomato. This thing is working everywhere the way it should, on every band, the way it's supposed to. Now I got to put the face on it and put the side covers back on it. And we're going to run this thing out. And we're going to see what it does, fully chooched on the 10 meter position, of course. So, give me a second, we'll be back. Alright. So, we got a little bench 2 pill hooked up. And looking at the same thing again. Right now we've got this in the 5,000 watt position, 1,000 watt, and 5 watt second reverse. So we're going to start out right there. We're going to go to the 1,000 watt position, so that's 1,000 watts in PEP. About 230 peak watts that we're going to put in this thing. 230, 250. No more than that, you guys. You start burning up parts after that. Not that the tube can't take more drive, it's that this guy can't handle the input power. So, disappears, right? Take our doubler, that now reads 2,000 watts. Off the scale again. So we're going to go down to the 5x position. 800 and some bird. And about 2,500 peak watts. Let's look at our meter in the front of the amplifier as we're doing this. And we're driving it this hard for a reason. Because if it's going to fail, it's going to fail running it like this. Hard. Very hard. Is it appropriate to run this thing like this? And can it do this? Yep, sure can. So, if you're watching this in 4K Ultra, which I hope you are, or at least 1080p, you should be able to make out the watt meter in the background. And still, with these super bright white LEDs that this guy's got in here, be able to read what's going on this meter. This is the one we're looking at. See what we're doing to our grids on the tube. When the amp is properly tuned, and you use your grid meter to achieve your output power, the grid meter barely wiggles. Plate amperes go down, output power goes up. It's that simple. Well, guys, you know what my family's doing right now? They're in our backyard, and we're setting up our big, ginormous, like 36-foot long above ground swimming pool that we have in our backyard that we set up every year for my kid and all of her friends to play with in the backyard. Look, this is one of the last sb220s I have sitting on my shelf. I think I've got 2 more over there. So we're slowly whittling our way through the pile. The reason I bring this up is because if you got one out there that needs to get worked on, I'm one of the last few people still working on this big heavy stuff. We've got a fairly large inventory of parts set aside waiting for me to be able to repair your stuff. Replacement faceplates, replacement cabinets, replacement floor pans. I've really taken my time in making myself ready to work on these things. If you like what you've seen, and you want to spend $300 or $400 and you want to get your sb220 running again, or any 3500 Z-Base box for that fact, send it here. I will take care of you. Call this number. Text this number. And I will get with you. And remember, calling me multiple times will not help me get back to you any faster. Like when I was putting the face on this, I had a gentleman call me 3 times in a row from California. I'm going to finish this and then I'll call that guy. So just be patient. Remember, there's one of me and a whole bunch of you guys, and I'm trying to work through everybody as well as I can in an efficient manner, as best I can without depriving myself from my family. So seriously, on that note, I don't get to be here doing this stuff without you guys. I really don't. I don't get to have this fun unless you guys are willing to send me projects, and I appreciate everybody sending me all the work that you have. All 38 or 3900 amps at this point. I appreciate everybody, and I'm here to service the entire community, not just the amateur guys and not just the chicken banders. I'm here to work for everybody. Appreciate y'all. Now I gotta go. I'm gonna go help my family set up the pool and have a little bit of family time. I'll see you guys. Bump bump.